everybody. Today's shout out is going to go to, Laron, because it was her birthday on Sunday. Imagine how much better that would have been in the classroom with all of us singing. Today's goal is that we can solve quadratics using square roots. Yesterday you looked at solving quadratics by graphing, which is not a very efficient method of doing it because if your parabola is not perfect, you can't tell where it's crossing the x-axis. And that's what we're looking for when we solve it. We're looking to see where the parabola would cross the x-axis. Sometimes it will cross at exactly one point. It will just touch down and we'll have one solution. Sometimes a quadratic will cross and have two solutions. And sometimes you'll get a quadratic that doesn't touch the x-axis at all. And in that case, we consider that no real solutions. And you will work with those in Algebra 2. So let's get started with today's goal is to solve using square roots. This method does not always work, but when it does work, it's very easy. So let's get started. So to solve using square roots, you're going to solve algebraically the way that you solve any other equation. So some quadratics can be solved simply by finding square roots. This usually happens when there's no middle x term. So you just have your x squared and you have some constants, and then you can solve algebraically using square roots. For example, here, x squared minus 7 equals 9. You can add 7 to both sides to get rid of the minus 7, and you would have x squared equals 16. Then you could take the square root of both sides. The square root of x squared is just x. The square root of 16 is both positive and negative 4. Remember that square roots of numbers can be both positive and negative, so every number has two square roots. So now we're going to try some. So we're going to use a combination of just algebra and square roots. So this first one, 11y squared equals 11. I'm going to start, I want to get my y squared by itself. So I'm going to divide both sides of the equation by 11. I will end up with y squared equals 1. So now I want to do the square root of both because I want to know what y is. I don't care about y squared. The square root of y squared is just y. And the square root of 1 is both positive 1 and negative 1. So I can write plus or minus 1, I could write it as plus 1, minus 1, I could just write 1 and minus 1. Those are my two solutions, roots or zeros for this quadratic. For my next one, I'm going to get the m squared alone by dividing both sides by 9. So I end up with m squared equals 169 over 9. I'm not going to actually divide that out because I noticed that both of these numbers are square numbers. And if I'm going to square root both sides, it's easier to have square numbers because you just unsquare them. The square root of m squared is just m. If you have a fraction inside, you're going to unsquare both the numerator and the denominator. So I know that m is going to be positive and negative 13 over 3. You do not need to change that to a mixed number. You can leave it as an improper fraction. So those are my two roots for that quadratic. Now our next example over here, 4r squared minus 7 equals 9. I'm going to add 7 to both sides to get rid of the minus 7. So we'll have 4r squared equals 16. Now I need to divide by 4 to get the r squared alone. When I divide by 4, I get r squared equals 4. I'm going to square root both sides because whatever you do to one side of the equation, you do to the other side. And I'm going to get r equals positive and negative 2. For my next one, I'm going to start by subtracting 81 from both sides. And I'll have 16m squared equals 0. I'm going to divide by 16 to get my m squared alone. So I'll have m squared equals 0. I'm going to square root both sides. The square root of 0 is just 0. There's not a positive and a negative 0. So this would be an example of a quadratic that would touch the x-axis at just one point, and it's touching at 0, 0. Now there are some special cases with quadratics, just like any other equation. Here, if I start off, I'm going to subtract 13 from both sides. So I will get z squared equals negative 8. When I go to do the square root, we don't do the square roots of negative numbers. It's not a real number, and we're not going to actually touch those until Algebra 2. So if you get the square root of a negative, you are going to write NRS, which means no real solution. So if you graph this quadratic, it would not touch the x-axis. Now there are sometimes when you don't get all of those problems worked out nicely. Sometimes it doesn't work out nicely. Can you grab some more? Alright, so for these examples, if I start off doing what we need to do, I'm going to add 8 to both sides of this first equation. So I will get 7x squared equals 21. Now I'm going to divide both sides by 7, and I get x squared equals 3. If I take the square root of both sides, I get x equals the positive and negative square root of 3, because those will be the two places that this will cross the x-axis. Now that doesn't work out nicely. To be an integer, it's going to be an irrational number. Sometimes you're going to be asked to leave your answer as a simplified radical, so this would be our solutions. Sometimes you're going to be asked to find a decimal for it. You would use a calculator, you would type in 3 square root, and you would round it to the nearest hundredths. Notice I'm now using the wavy equal sign because that means approximately. So the other way I could write my answer is I could say x is approximately positive and negative 1.73, which is the square root of 3. This is more exact. This makes more sense when you look at it. You know exactly about where it would be on the number line. Not exactly, but you know approximately where it would be on a number line. So these are two different ways of writing your answers, and you just need to pay attention to directions when it comes to how you're going to write your answers. For the next one, I'm going to start off, I'm going to subtract 15 from both sides. So I would have negative 6y squared equals negative 30. Now I'm going to divide by negative 6 on both sides. So I will get y squared equals 5. I'm going to do the square root on each side. So y equals the positive or negative square root of 5. You still want to make sure you're including both the positive and negative. So this is one way, which is a very exact way of writing your answer. It's a radical. Another way is to use a calculator and do the square root of 5 on the calculator. And if you do the square root of 5 on the calculator and round it to the nearest hundredths, you would get approximately 2.24. So y would also equal approximately positive or negative 2.24. Two different ways of writing your answer. Now for our last one, I'm going to erase this so we have enough space. I'm going to bring over the minus 50 as plus 50, so I will have x squared equals 50. I'm going to do the square root on both sides. So I know that x equals the positive and negative square root of 50. If you need to write your answer as a radical, This would not be accepted because you can simplify this. We're going to do a factor tree, 5 times 10 and then 5 times 2. So you have a pair of 5s that can come out. The 2 stays in. So the simplified radical form of the answer would be positive or negative 5 root 2. The other way is to get the decimal numbers. When you're doing your decimal numbers, it's easier to not simplify your radical and just type in 50 and then square root. And you would get approximately positive or negative 7.07. You want to make sure you practice with the calculator and know how to get the square roots with the calculator. So those would be the 2 solutions roots of zeros, 2 ways of writing it. This one is more exact because here we had to round. But this one makes more sense to people when they see it because they know where 7.07 is approximately on a number line. Now for our next ones, there are times when you have the middle term that you can still use square roots. And I'm going to show you these 2 examples and you can look at the other one for yourself. So if I want to try and solve this example algebraically, 5 is being multiplied by this whole parentheses that's being squared. So I'm going to start by dividing both sides by 5. And I would get x minus 1 squared equals 8. Because this whole thing is being squared, I can square root this whole entire side, which would make it just x minus 1. So x minus 1 equals, and I have to square root the other side, square root of 8. Positive or negative square root of 8. So right now this is where I'm at. I need to still solve this. I need to get x by itself. So I'm going to bring the 1 over as positive 1. So I will have x equals 1 plus or minus the square root of 8. Now, one way to leave your answer is to leave it like this, but make sure you simplify your radical. And if I simplify square root of 8, I can take out a 2 and have it be 2 root 2. So one way to write your answer is to write x equals 1 plus or minus 2 root 2. This is the most exact way of writing your answer. The other way, and it's very common for teachers to ask you to do that, is to give the decimals rounded to the nearest hundredth is generally what we do. So to do this one, we're going to do 1 plus square root of 8. Then we have to do 1 minus square root of 8. It's not as simple as getting one decimal number and writing plus or minus. We're going to get possibly 2 different decimal numbers. So on a calculator on my phone, I'm doing 1 plus 8 square roots, and I get approximately 3.83. So you want to make sure you can do that on a calculator and get that. So this is doing 1 plus. Now I need to do 1 minus 8 square root equals approximately negative 1.83. So these would be my 2 decimal approximations for this. For the next example, I'm going to divide by 4 on both sides. So I'm going to get z minus 5 squared is the same thing as 3/4. And to make the calculations easier, I'm going to change it to 0.75. So now I'm going to square root both sides, and I would get z minus 5 equals positive or negative square root of 75. So when I'm going to do my decimals, I'm going to use 0.75. For my simplified radical form, I'm going to use the 3/4. So I'll write that one over here. So I would have z minus 5 equals positive or negative 3/4. So I need to finish off both of these and then simplify them. So I'm going to bring the 5 over, so I get z equals 5 plus or minus the square root of 3/4. Square root of 3/4 can still be simplified. If you remember, I can give both parts of the fraction their own radical. Square root of 4 becomes 2. And I can't simplify square root of 3, but I can leave it because you can't take anything out of the 3. So I would have this as my final simplified radical form. For my decimal form, I'm going to bring over the 5 as plus 5. And now I'm going to use my calculator. I'm going to do 5 plus the square root of 7.75. And if I do 5 plus 0.75 square root, I would get approximately 5.87. And now I'm going to do 5 minus 0.75 square rooted equals 4.13. So those would be my 2 decimal approximations for this. So on the bottom it tells you how to use your calculator, and different calculators work differently. So if you're not sure how your calculator is working, you're not using your phone calculator, using another device, let me know, send me a message, and I can help you figure out what buttons to hit if you can't get the same answers that I just got, and the answers when we try the practice problems tomorrow, because you want to make sure you know how to enter it, because if you've done all the work of getting a solution, you want to make sure you can represent it correctly. Have a good day.